On questions 11 and 12, I want you to solve the system by the best method for you. And by the best method for you, I'm telling you, substitution or elimination. Because you don't know what the answers for graphing are going to be, whole numbers or nice numbers to work with. So let's just concentrate on substitution and elimination. On question number 11, notice they're in columns. So I think substitution would work best here. And I also notice that I've got 10y and a negative y. So if I just multiply the top equation by 10, I'll get my y's to cancel out. So 10 times 3 is 30x minus 10y equals 1490. Well, if I add them up, I get 55x. Notice the reason I did this is my y's are going to cancel. And we see 5 plus 0 is 5, 9 plus 1 is 10. Carry the 1, we get 9, 3905. I'll divide both sides by 55. I think I'll use a calculator for that. And it turns out that x is 71. I think I will still want to use my first equation before I multiply by 10 to solve for y, because I think that works out pretty nice. So 3 times x, which is 71, minus y equals 149. Well, notice 3 times 7 is 21, so we get 213 minus y equals 149. So let's subtract 213 from both sides. And need to pull this up a little bit so we can see it. And then we get negative y equals 13 minus 9 is 4. 10 minus 4 is 6 equals negative 64. So y is positive 64. So 71 and 64 would have worked with graphing, because they turned out to be whole numbers, although they're not very nice numbers. You're going to have to scroll a little bit and try to find where they intersect. So that probably, I still think, elimination works best here. Now, on the next one, notice, I think substitution would work best here because they're not columns, are they? And I don't see by moving them. So let's do this. Let's multiply the bottom of the equation by 3 so I get rid of my fraction. So we get x equals 6x. 3 times 2 is 6. Not x. Let's try that again. 6y minus 3. Well, that works out nice for substitution. So in my first equation, I'm going to say 8y equals 1 1/2. I think I'm going to write that as 3 halves. Although you could write it as 1 1/2 if you want. It's not going to matter. Minus 2 times 6y minus 3. Well, let's simplify that a little bit more. So I get 8y equals 3 halves minus 12y plus 6. And I can combine my 3 halves and my 6. That's not such a bad fraction. I'm going to rewrite my 6 with a denominator of 2. So I get 3 halves minus 12y plus 12 halves. 12 divided by 2 is 6. Now we can combine our numbers. So we get 8y equals 15 halves minus 12y. Well, let's add 12y to both sides. So we get 20y equals 15 over 2. Now, to explain this, I think it's easier if we don't have any fractions before we start solving. So let's multiply everything by 2. So then we're going to get 40y, 2 times 20 is 40, equals 15. I'll divide both sides by 40. So y equals, notice I can divide by 5, can't I? 5 goes into both of them. 15 divided by 5 is 3. 40 divided by 5 is 8. So y is 3/8. Now let's go back and let's find x. And x equals 6y minus 3. So let's go ahead and do that one. So we're going to go 6 times, we said, y is 3/8 minus 3. Well, 6 and 8 don't reduce, but notice 2 goes of them. So 6 divided by 2 is 3. 8 divided by 2 is 4. So 3 times 3, I get 9 over 4 minus 3. Common denominator is 4. So it'll be 9/4 minus 12/4. And 9 minus 12 is negative 3/4. So, as an ordered pair, x is negative 3/4, y is 3/8. I don't think you would have solved that or found that accurately using decimals, especially to write it as a fraction for an answer. So, that's why they want you to use decimals. Okay, let's take a look at number 14. Now, when you get to word problems, it's fine to have decimals. It's fine to use decimals as long as that application works like for a whole number or something that is kind of nice. Now, number 14, this is a numerical question, so I don't think I'm going to want to use decimals on this because I could get decimals here. I never told you it's limited to whole numbers. So 3 times one number, I'm going to call that first number x, I think. And add it to 5 times the second number, so 5y is 68. So when I write my system here, I'm going to say 3x plus 5y is 68. 3 times the second number, well, my second number is y, so I'm going to go 3y minus 4 times the first number minus 4x equals 6. I think the first thing I'm going to do, I'm going to put them so my x's line up. So I'm not going to change anything on my first equation. But my second equation, I'm going to go negative 4x plus 3y equals 6. Now they're in columns, but there's nothing matches up. I don't have a coefficient of 1, so I'm not going to use substitution. Let's use elimination. Let's get rid of the x's. So what I'm going to do is I'm going to multiply the first equation by 4. I'm going to multiply the second equation by 3, because that way they'll cancel out. So 4 times 3 is 12x plus 20y equals 68 times 4. I think I'll use my calculator for that. 68 times 4 is 272. My second equation will be negative 12x plus 9y equals 18. Well, when I add them up, notice my x's cancel out. That's the reason we did it. So we get 29y equals equals 290. Well, that works out really nice because y is 10. I think I will use my second equation because they look like they're smaller numbers to work with. So I'm going to use this one. I'm going to solve for x. So I'm going to go 3 times 10 minus 4x equals 6. So that's 30 minus 4x equals 6. Let's subtract 30 from both sides. Negative 4x equals negative 24. Divide by negative 4, and x is 6. And then what are the two numbers? So answer your questions. It's an application number. I would just say the two numbers are 6 and 10. There's your first application dealing with systems.